Hello there. In this video, we are going to be looking at how we can use our normal distribution to investigate and calculate when we have been given percentages and we need to find the critical cutoff points. So in this case, remember from our median, right, 50% of the data is to the left and 50% of the data is to the right. And we know some other cutoff points from like our empirical rules, but what if we want something more kind of detailed than that and we want to know where these cutoff points were? So let's say like we're interested in where is the lower, let's do 75% of the data at. Okay, so when we do this, we can ask for these cuts, these left and right cuts, if we give some percentages. So the first thing that we need to do is we need to make sure that we are going to be clicking on the quantiles, because that changes how the shading is done. And quantiles say, like, give me a percentage and I'll show you where that bottom percentage is. So this left area, we're going to put at 0% because we're going to go from 0 to 75%. And it shades in the lower 75% of the data on our distribution here using the mean and the standard deviation for our graphs. So it gives us that this left cut is at negative infinity, because remember 0% shaded is at negative infinity, and then the right cut is here at 133.4898. So that's how we would find the lower 75%. Let's say, what about the upper 75% of the data? Okay, all we have to do is change this to be 0.75 and then make the right go to 100%. And if we do that, oops, sorry, that's the upper 25%. If we want the upper 75%, we have to go from this lower 25 all the way up to 100%. That would give us our upper 75%. So that would give us this answer of this lower cut of from 106.5 to infinity. So if we wrote that out, let me put those down right now. So we'd have this this lower and upper. This is going to go into infinity. A lot of times I just do two little O's for infinity, and the lower is just going to be that 106.512. And we can flip that around once again, just so that we've got some practice for this, from 0 to 0.75. Gives us, for this one, if we did a lower and an upper, the lower here would be negative infinity, and the upper is going to be, let's get rid of that equal sign, negative infinity, and the upper is going to be equal to 133.4898. So we've got our lower, we've got our upper for when we're dealing with 75% of the data. Now, let's say we want to know between 2 points. So we could also look at like the middle 50%. So let's say I want to know where the middle 50% is. And so this would be like, AKA our IQR. This is our middle 50% of our data. Well, we know that a normal distribution is evenly distributed, or is equally, it's symmetrical, right? When we fold it across our midline. And so we could go from our 25% point on the lower end, 0.25, to the 75. And we know that here, from 25 to 75 is 50%. So this gives us the middle 50% of our data, and we have that our middle 50% is in between these upper and lower points. We can also do like between like the bottom 15% and the upper 90%. So if I did like, let's do 15 to the upper, to where the 90th percentile is, and I hit enter, and it'll shade it like this. So we can use our quantiles to find those. So let me show you how you can do these by hand. So if we see our quantiles gives us the equation that we use is this norm dot inverse. So the norm dot inverse is what we're looking for. and how we can get this like lower 75% of the data. Let's go look at it. So if we type equals norm dot inverse and do a parentheses, it's going to ask us for some information. So it's asking us first for the probability. So the probability that we're interested in the lower 75%, is going to be the 75% mark, 0.75. Now we have to remember that norm.inverse always gives us the area from a critical point and to the left. So let me show you this. Norm.inverse, oops, we'll escape that. We'll go back to that. So when you are doing norm.inverse, it is always doing this shading. So it's giving you from a point and to the left. If you want to find between points, we can do that. That's totally fine. And if you want to find above a point, we have to take the, we'll work through that. But just know that it's always finding the area from a critical point and to the left. So for this one, where's the lower 75% of the data, we can do equals, again, norm.inverse. And we can put in 0.75 as our probability. The mean, we have two options. We can either do like these means and standard deviations, or we can just use the standard normal of 0 and 1. And honestly, either one works totally fine. So I'm just going to do 0 and 1 because I know that the standard normal distribution, the area is going to be the same. Now, if I do this though, it's only going to give me the z-score, so this would be the z-value. And if I want to find that upper and lower, here's what I can do, or find this upper value, right? It's going to be equal to our z-score multiplied by our standard deviation. We have to add to it the mean. And all I've done is I've just reorganized the z equation to solve for a critical point. And if I enter, I get this 1.33. So that's how you would do it if you were using just the standard normal and then moving to a critical point. But what's cool is that this, if we use our norm.inverse and we do the probability on 0.75, and now if we give the mean here as 120 and our standard deviation as 20, it will give us the answer in terms of our scenario. So we could get the z-score and we can do our scenario from what 75%, the lower 75% of the data is. If we want to find between 2 points in doing this, we'll have to find the area between one and then the area on the other side, and then we can give us the cutoffs for the specific ranges. So let's look at the between, do one more example. We'll do between upper 40 and 20 percentages. And we want to know what the cutoffs are. Okay, so we want to know the lower cutoff, and we want to know the upper. Okay, let's do this using our tool first, and then we'll practice doing it by hand. So if we want the upper 40%, that's the same as saying the lower 60%. So we're going to put in 0.6. And for the right, we want the upper 20%, so that's going to be 0.8, because I had to do the upper 20. Remember, quantiles always do things from the left. So if we want the upper 20, that's the same thing as saying the lower 80. If I want the upper 40, it's the same thing as saying the lower 60. So if I put those in, I get this little sliver of between the upper 40 and the upper 20 percentages. So I get those two. And here are my two cutoffs. Okay, if I want these, I can do equals norm.inverse. And I'm going to ask for this probability. So because I want these uppers, I'm going to do in here 1 minus 0.4. comma, so that'll give me, I did the 1 minus so that it's the upper 40, it's flipping it, it's 100 minus the 40, that gives me the 0.6 like we did up here. And then I can put in the mean and our standard deviation. And if we do those, it gives me this answer of this 125.067 here, just rounding to 3 decimals. We could give it more if we wanted. And then the upper cutoff is just going to be equals to norm dot inverse of 1 minus 0.2, comma, mean, click on the mean, and then the standard deviation of 20. And if I hit enter there we go, I got my 136. That's where I got this cutoff of 136. So if we notice that now we're able to, if I give percentages and I want these cutoff points, we can do those. And that's using the quantiles. And then as we did previously, if we are given cutoff points and we want to know the percentages between them, we can do that too using the values and using the norm.dist. So be sure that you practice these, because remember, you will not have this whole very nice tool set to use on the exam, but you will have the availability of the norm.inverse and the norm.dist. Hope that helps you out. Good luck.